All right. Last section of chapter 11 is 11.6. We kind of go away from the probability stuff for just a little bit and talk about some statistics things and ways to measure data. So our EQ is how can I compare sets of data using measures of center and box plots. So as a warm-up, we're going to use this two-way table to find some probabilities real quick. What is the probability that a student is passing their homework or has a passing grade on their homework and their summatives? So if it's probability of this and this, I'm picking from everybody, right? Because there's no given event. It's just saying if I pick someone at random, what's the probability that they are passing both their homework and their summatives? So if I make some totals here real quick, 58, 36. Either way, that adds up to what's that, 94? So 94 students total. So out of 94 students, how many are passing both their homework and their summatives? That would be those 50 students, so it's 50 out of 94. That can be reduced, but I'm concerned with the 50 out of 94. 0.532, enter, or 25 out of 47. 0.532, so 25 out of 47, or 0.532. What is the probability that a student is failing their summatives given that they are failing their homework? So given that they are failing homework, that would be these students. So I'm talking about 32 people. What is the probability that they are failing their summatives as well? Well, that would be 24. So this is 24 out of 32, which I know is 3/4 because those can both be divided by 8. So you have a 75% chance of picking a student who is failing their summatives if they are failing their homework. And then finally, what is the probability of choosing a student who is passing their summatives given that they are passing their homework? So again, the homework is the given event, so I am talking about these people passing. So of 62, how many of them are also passing their summatives? That would be 50. So 50 out of 62 is 25 out of 31, or 25 out of 31, 0.806, 0.806. So it's an 80% chance that a student is passing their summatives if you know they are passing their homework. So those are the two-way tables that we covered in section 11.4. But again, now we're going to move on to some new stuff or talk a little bit more about data. So there are three ways. There's more than three, but the three main ways that we talk about measuring data. So if you have a survey, and you ask someone a numerical question so that the response is a number, like what percent do you have in English class, how many siblings do you have, things like that. You can measure the center of the data in three different ways. There's the mean, the median, and the mode. All terms that you've heard before. The mean is the average of all data values, meaning we're going to add them all up and divide by the number of data points. So if there's five people responded, you add up all their numbers, divide by 5, that gives you the mean. The median is if you line up all the numbers from least to greatest, what number is right in the middle. And then if there's like two numbers in the middle, so for example, if it was like, these are my results, 1, 2, 6, and 8, right? There's actually two numbers in the middle, not one clear number. And so if there's two values in the middle, then I'm actually going to just average those two out. So in this case, the median would be 4 because that's the average of 2 and 6. And then there's the mode, which is a pretty inexact measure of center, but it's just what number shows up the most often. So there's not a real good way for that. You just have to visually scan and see, okay, that number shows up a lot, and it shows up more than any other number does. Okay, so just to run through quick, what are the mean, median, and mode of the data set? I'm going to start with mode, actually, because that's the first one that requires no calculation. I just have to look. I see that there are 3 shows up twice and 5 shows up twice. So it is possible to have 2 modes. Okay, so I've got both 3 and 5 for a mode. If every number shows up once, then you would say there's no mode because there's no duplicates, but you can have many modes in a data set. The median, I learned to just like cross off from the edges. So take out 9 and 1, and then take out 5 and 2, 5 and 3. And then in the middle, I have 3 with 4. If I take those numbers and find the median, not the median. If I take those numbers, add them up, and divide by 2, my median is going to be 3.5 of the data set. And then finally, we have the mean, which means I'm going to add them all up and divide by 1, 2, 3, 4, 5, 6, 7, 8. There are 8 values, so I'm going to divide by 8. If I take all those numbers up, let's see, that's 10, that's 20, that's 30, so 32 over 8, which is 4. Okay, so our mean was 4, our median is 3.5, and our mode is both 3 and 5. Again, just different ways to measure the center, but all of those values are in the same ballpark, which is good. Okay, so another way that you can find, another way that data can be displayed is in what's called a frequency table. So if you look at this, this shows the number of job offers math majors were offered, or math majors received upon graduating. So the way you would read this is like some students got 0 job offers out of college. How many did that apply to? Well, that applied to 2. So the frequency is the bottom number, or how many times did the top number happen? Okay, so this is saying 2 students received 0 job offers. The next column tells me that 2 students received 1 job offer each. The next one says 4 different students received 2 job offers. So if I were making a list of this data, I would write the number 2 4 times. And then next is the number 3 5 times, because 5 different students got 3 job offers. And finally, 2 people got 4 job offers. Okay, so this would be my data set written out the long way. I'm going to take this, put it here, and then take the whole thing. Okay, so we could find the mean, median, and mode by hand. Okay, the mode's actually pretty straightforward because the mode is what number shows up the most often. And here I see that there's one number that showed up 5 times. So the mode would be 3, right? It's not how many times did that number show up, but what number showed up the most. And 3 was the most common number of job offers. The median, again, I could just go ahead and cross these things out. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 1, 2. So I have 2 in the middle there. So 2 is my median. And then finally we have the mean. The mean is the only one that's kind of annoying to do. But one way you can kind of shortcut this is to, we think about there are 2 students, 2, 4, 5, and 2. If I add all those up, that's going to tell me how many students we're talking about here. So it's 10, 15. So 15 students total. And then to find the total number of job offers, right, because I'm going to add up all those numbers and divide by 15, I'm just going to multiply those, right? So 0 job offers to 2 students is 0 total job offers. 1 job offer to 2 is 2 total job offers. Those 4 students had 8 total. Those 5 students had 15 total. And then that's 8. So I'm going to add all those up. 10, 25, 33. So that means there were 33 job offers spread across 15 different students. So I'm going to take 33 over 15 to find my mean. And that's going to be 2.2, I'm pretty sure, but let's double check. 33 out of 15. Yep, 2.2. So the average number of job offers that a student got was 2.2. Again, all those numbers are in the same ballpark, right? My mean, median, and mode are all pretty close to one another. So that's a frequency table. Just another way to that data can be displayed. We are going to use the calculator for a lot of this section. Okay, so I'm going to show you how to type this stuff into the calculator. One key is that the mean and the median are of the three measures of center, mean and median are used the most. And so the calculator will tell you the mean and the median. It will not tell you the mode. So that if you're asked what is the mode of a data set, you do have to just visually scan and figure that out. This data set right here actually doesn't have a mode because no number is repeated. So what we're going to do is use the calculator to find the mean and the median quickly. So everything that we're going to do is in the stat menu, which is right up here by the left arrow key. I'm going to go ahead and hit edit. If there's any numbers in that calculator, I can go up to L1, hit the clear button, and go back down, and that will clear out all the data that the previous user put in there. So I'm going to type in 2, 5, 10, hitting enter every time to move to the next cell, 13, 3, and 7. The nice thing about using the calculator is you do not have to order this from least to greatest. It can be in any order that you want. So now that I have that entered in, okay, I'm going to hit the stat button again. I don't need to edit because I already got that. The sort A and D, or ascending and descending, so you could have the calculator sort it for you from least to greatest. I don't really care about that. We're going to go over to calc. And since we're only comparing one value, that's this first menu, this one var stats, means single variable statistics. So I'm just going to hit enter. I have list 1. I didn't have a frequency list, so I can just hit enter through this. You're basically just going to spam enter until you get a bunch of information on your screen like this. So lots of numbers. You'll see this down arrow, so I can even keep scrolling down, and it tells me a lot of information about that data set. What I'm intrigued by, or what I care about, is this top line. The X with the bar over it, shocking, math people call it X bar. That means the average, or that gives you the mean of your data set. Dang it. So X bar is the mean of the data set. That was 6.6 repeating. Okay. It's going to pop up in a second. Close this out. And then the other one that I care about is the median. Oh boy. And the median is going to be, if I keep scrolling down here, MED, that tells me the median of the data set. So the median is 6. Again, the mean and the median generally tend to be pretty close to one another. So that's how we use the calculator to tell us those things. All of this other information is actually, not all of it, but most of it's pretty prevalent and important. And we're going to talk about the rest of the stuff and what it means in just a little bit. All right. So one way to quickly summarize a data set is to draw what's called a box plot. You may have remember them from middle school or elementary school as box and whisker plots. A box and whisker plot looks something like this, right? There's like a box in here with a line in it, and then you got whiskers coming off the edge. We'll talk about what all that means, but you'll notice there are 5 vertical lines in a box plot, and those 5 values, those 5 numbers that make up the vertical lines on a box plot are what are called the 5-number summary. Okay, and it's a statistical way to kind of summarize all of your data set very quickly. So the first and the last number in the 5-number summary are just what is the minimum value. So what is the smallest data value you have, and then what is the maximum data value that you have. Okay, so those are kind of the bookends. Okay, those are the outsides of the box plot or the 5-number summary. In the middle is the median. Okay, so that we use the median, just standard regular old median. And then in the middle between the median, so the median cuts the data set in half. Okay, so what this is really saying is 50% of the data is right here between the minimum and the median, and the other 50% is right here. You may have heard of percentiles before. We're not going to get too much into percentiles, but it is something that if you continue to study statistics, you'll learn a lot more about. Then if you just focus on the lower half of the data, so the lower 50%, the number that splits that in half is called the first quartile. Okay. Quartile obviously has a root word of quarter. And the reason is because 25% of our data falls between minimum and first quartile, and then 25% of our data falls between first quartile and the median. So we have the first quartile, we have the median, which is technically the second quartile. Second, 2 out of 4 is halfway. So then the third value is the last value to fill out is what's called the third quartile. Okay, so we have 25% of our data between the median and the third quartile, and then 25% of our data between the third quartile and the maximum. Okay, so that those 5 numbers kind of split the data into quarters or into fourths, and that makes up what we call the 5-number summary. And we're going to actually use those 5 numbers to create the box plot. So now the nice thing about this is that in the calculator, if you scroll down to the bottom, you'll see that like the 5-number summary is the last 5 numbers in this list are the 5-number summary. So we don't have to go too far to find that value or to find those numbers. So let's put this into practice real quick. Here's what a box plot's going to look like. Okay, so you've got a line. It'll always be expressed on a number line. So you have something like this. Here's the minimum. This is the maximum. And then the box itself spans from the first quartile to the third quartile. So in here, this is Q1, this is Q3, and then the line in the middle of the box, it's not always in the middle, but the line in the box tells you where the median's at. So if I were to look at this, I could reasonably say that it looks like the minimum is 2, right? Somewhere in between 0 and 4 there, looks like at 2. The maximum is 14. Just to keep this in order, we're going to move this down. The number that's, now again, when I say the number in the middle, I don't mean visually in the middle, but we're talking about the median, which again cuts that data set in half. That I'm looking at the line inside that box, which looks to be at 6. So the median would be 6. Q1 and Q3 make up the last 2 numbers, and those look like they are at 5 and 9. 5 and 9. Okay. So a lot of vocabulary being thrown at you. 2 other pieces of information that are really helpful to kind of tell us how spread out the data is. So is it bunched together or is it really spread out far? 2 values that the calculator won't tell you, but they're a pretty quick calculation, are the range of the data set. I'm going to switch colors here. So I have the range of the data set. And you may remember learning about range. All of you have learned about range at some point in time. That is the maximum value minus the minimum value. So basically, how far does your data set span? What's the distance from lowest lowest value to highest value. And then we have what's called the interquartile range, abbreviated the IQR. Okay. And it's the same idea, but now we're just talking how far apart are the first and third quartiles. So this is going to be Q3 minus Q1. Okay. So max minus min for the range. IQR is just third quartile minus first quartile. So here the range of our data set would be 14 minus 2, which is 12. So that's the range. And then Q1 third quartile minus first quartile gives me 4. So that is the IQR. Again, like out of context, that doesn't really help you a whole lot. But again, if you take a stats class, or if you are in any sort of data analysis, sometimes you'll use the range and the IQR to compare how spread out a data set is. So there's actually 7 values there, not 5. Okay, so we're going to create a box plot, fill out all that information. Okay, we're going to actually create this on the number line. So what I need to do is go to the calculator. Okay, you could do all this by hand, but it's so much easier just to type in the calculator. So I'm going to clear out the data set. I'm just going to type in these numbers. Bear with me while I see if I can use the keyboard. 1, 3, 3, 5, 6, 8, 8, 8, 10, 12, 12. Nope. Oops, too quick. 12, 12. And man, this is a spot where you make a silly mistake because you move too quick typing these numbers in, and you are guaranteed to get a wrong answer. So just take your time typing this stuff in. So looks like I've got 15 numbers in this list. I'm gonna double check real quick. 1, 3, 3, 5, 6, 8, 8, 10, 12, 12, 15, 15, 16, 18, and then blank. Okay, so there's my list that's entered. We're gonna go stat, over to calculate, hit enter, and again, just kind of spam enter until you get what you want there. So we're gonna go down the bottom of this list. We got 1. So I'm looking at that 5-number summary right now. This n value, this just tells you, kind of like when we did sequences in the last unit, how many numbers do you have? So n equals 15 means I have 15 values typed in that list. So I'm going to fill this out quick. 1, 5, 8, 15, and 18. Okay. So now we go back here. There's my 5-number summary. So to actually create this box plot, you have some flexibility. Just make sure that you label. I'm not even going to make you like number by ones or whatever. I'm just going to go by 2s here. 1, 3, 5, 7, 9, 11, 13, 15, 17, and 19. Don't need to go further than that because 18 is my maximum value. So I'm going to put a vertical line at each one of the 5 numbers in the 5-number summary. So there's 1. I got a max of 18. Third quartile is at 15. Median is 8. And the first quartile is 5. Okay. So then I get, these are the whiskers going from the minimum to the first quartile and from the maximum down to the third quartile. And then the rest of this, I'm going to create the box. Oh boy. So the box spans from Q1 all the way across to Q3. Okay. So there's my box plot. And then the last thing we're going to do is figure out what's the range and what's the IQR. So range is going to be 18 minus 1, or 17. And then the IQR, you take third quartile minus first quartile, that gives me 10. And again, like range and IQR might not seem useful right now, and it's kind of because we're not using it in a useful manner. But it's important information or topic when we're talking statistic or statistical analysis. Okay. Last thing we have to talk about is just kind of again, something that we're not going to really dive deep into, but maybe one of the most used statistical like pieces of information besides mean, median, and mode, and that's the standard deviation. Okay, the standard deviation is given to describe roughly how spread out a data set is, and so, and this is you go like if you ask a stats teacher, this is not a true definition, but this is roughly what the standard deviation tells you. It's a single number, and it tells you on average how far is each number or each data point. How far is that from the mean? Okay, so I don't want to get too deep into it. Again, if any of this interests you, like get into statistical analysis. Having a stats background helps in so many different ways. I know Mrs. Lucan like uses stats all the time, and she's not in a math field, and so it's super helpful. And we talk standard deviation, which I'm sure sounds super exciting, but yeah, we're not going to be able to do it justice. But standard deviation in the calculator is expressed using this symbol, which is sigma. It's a Greek letter. So you'll see sigma x, and that tells you the standard deviation of a data set. So if you look on here, right above the n, which is how many data points do you have, then it shows sigma x, which is 5.05. Okay, so 5.05 would be the standard deviation, or 5.06, I guess, if we're rounding. That is the standard deviation of that data set that we typed in. So standard deviation, or again, you can use the sigma symbol. And again, not going to be able to do it justice, but roughly what the standard deviation means is that means so. So if you look back up here, right, the mean of that data set, I typed in 15 numbers, and the mean was 9.3 repeating. In a nutshell, if you were to take every single number in that list and calculate how far away is it from 9.333, so the minimum being 1 is 8.3 away from the mean, and if I did that for each one and then took the average of that, that roughly gives the standard deviation of 5.06. Again, that's a rough description of it. Just take a stats class and you can learn a little bit more about it. The homework for 11.6 is only 4 questions, 7, 8, 12, and 13. 12 and 13 ask you to make a box plot, but make sure you include our 3 additional descriptors of range, IQR, and standard deviation for those problems.